Welcome to the Theory and Operation on General Hybrid Introduction and Safety. This is an introduction of hybrid systems and the safety precautions you'll need to know. My name is Lance Wiggins and I'll be your host for this course. It's a great day to fix transmissions, so let's get started. Since the inception of the hybrid vehicle in 1999, over 4.5 million hybrid vehicles have been sold in the U.S. As of May 2018, the second largest in the world after Japan, which sold over 5 million, with more than 11 million sold worldwide. Sales of hybrid vehicles in the U.S. began to decline following the financial crisis in 2007 and 2008, and after a short recovery, began to decline again in 2014 due to low gas prices. Hybrid sales in America and the American market achieved its highest market share ever in 2013, capturing 3.19% of the new car sales that year, and dropped below 2% in April of 2016. A hybrid vehicle contains gasoline and electric parts of both type of vehicle. Likely, the other vehicles rolling down the highway the engine in the hybrid vehicle is doing one of three things, or all. Overcoming rolling distance in the drivetrain, overcoming air resistance, powering accessories that the alternator, the power steering pump, and the air conditioning. With the hybrid vehicle, you have a complete electric car, which includes an electric motor to provide all of the power to the wheels and batteries, to supply the motor with electricity, and a completely separate gasoline engine powering a generator. The engine is usually very small with no more than 10 to 20 horsepower, designed to only run at one speed for maximum efficiency to provide enough power for the vehicle at cruising speed. Let's take a look how the system operates. Most hybrids drive on their battery at slow speeds. This means, simply put, the vehicle is purely electronic at this time. During moderate to heavy acceleration, the hybrid will use the engine combined with the electric motor, especially during hill climbs or passing. At cruising, the engine operates alone, but can be shut off if torque isn't necessary and provided the driving conditions. During deceleration, when the vehicle is slowing down or braking, the motor becomes a generator for recharging the battery. This can happen on hill descending as well. While at a stop, the engine shuts down, but the vehicle system continues to run on battery. There are some important features you'll need to know that we'll cover when regarding working on these units. The different types of systems: series, parallel, and series parallel. The series hybrid is no mechanical transmission replaced with generator. Starts out with the electric motor. The electric motor receives electric power from a generator, which is run by the gasoline engine. The hybrid computer system controls how much of the power comes from the engine. The generator, or hybrid battery. The engine and generator both recharge the hybrid battery pack along with regenerative braking systems during coast down and hill descents. The parallel hybrid system, which is the most common, the engine and the electric motor both generate the power that drives the vehicle along with a mechanical transmission. The hybrid computer controls both the engine and electric motor to work together with the transmission. The electric motor and regenerative braking system both recharge the hybrid battery pack during coast down and hill decline. The series parallel hybrid is a combination of both a series and a parallel type system. Combining each hybrid type, both the engine and hybrid system can drive the wheels similar to a parallel hybrid system. In this case, the engine can be disconnected, so only the electric motor powers the wheels, such as series-type hybrid systems. During low speeds, this type operates more like a series hybrid. At high speeds, the engine drives the vehicle. Anytime you're working with hybrid systems, there are some serious warnings you must adhere to. Never leave the vehicle unattended unless the ignition is off and the transmission's in park. Keep the ignition key in your pocket whenever you're away from the vehicle. Some vehicles include auto start, which may automatically start or restart the engine under certain conditions, such as when the battery or the vehicle has already been turned on. Use extra care when positioning jacks or hoists. There may be high voltage wiring underneath these chassis. Some vehicles use a high voltage motor which will operate the AC compressor or cooling fans to automatically come on to cool the battery compartment if it gets too hot. Whenever service is required near the battery or other high voltage devices, always use the appropriate safety gloves. Never wear anything metal that might come in contact with the high voltage wire. Wait at least 5 to 30 minutes, sometimes even longer, model dependent, after turning the ignition off before isolating the high voltage battery pack or performing any service on the vehicle. Most hybrid vehicle high voltage batteries are nickel metal hydride and typically should only be recharged by the vehicle's own charging systems. Never connect a conventional battery charger to the vehicle. Even the auxiliary 12-volt batteries that most hybrid vehicles use are specially sealed. The hybrid system uses high voltage circuits, so improper handling could cause an electric shock and or serious personal injury. How will you protect yourself? Stay away from the orange wires. Well, only if you're not prepared. Hybrid vehicles' high voltage batteries can be isolated by using the factory isolation process. Once isolated, voltage is confined to the battery pack. Repairs can be performed safely. The battery pack is sealed at the factory and in an impact-resistant case. Leaking or explosive plates are very, very rare. These high-voltage systems can produce up to 750 volts or higher. Hybrid work area. Always tape off or cone off your area so other employees can see you're working with hybrid vehicles. Always wear protective gear, including gloves, face shield, safety glasses, aprons, etc. When working on the high voltage system, always wear insulating gloves, which are class 0 1000 volt certified. Wear protective gloves over the insulated gloves before working on hybrid vehicles. After removing the service disconnect, do not touch the high voltage connectors and the terminals for 5 to 30 minutes. Some manufacturers advocate a puff test, blowing into the glove to inflate it and check it for leaks. Although professional inflators are available, the most common approved field test is to trap air in the glove itself, then roll the cuff tightly to inflate the working area of the glove. Let's see how this is done. Visually inspect both insulating gloves inside and out for any flaws or damages. Especially check the expiration date. Using both hands, hold the insulating gloves by the edge of its cuff and let it hang naturally. Pull the cuff tight to trap as much air into the glove as possible. Keeping the cuff sealed, lay the glove on a clean, dry, horizontal surface with the fingers pointed away from you and start rolling. Roll the cuff towards the fingers to inflate the glove as much as possible without allowing any air to leak. You can damage the glove even if it's in good condition by doing this. So be very careful. Once you've reached a point where it's tight and it's not leaking, you're good. Listen for air leaks and watch the glove for any signs of deflation. Put the inflated part of the glove, fingertips and palm, close to your face and feel for any silent leaks. Insert the working area of the glove under water and check for bubbles. Do not allow water to enter the inside of the glove. Allow the glove to completely dry before usage. Repeat the test sequence for other gloves as necessary. OSHA, the Occupational Health and Safety Administration, has regulations to specify that rubber insulating gloves issued by the employer must be tested or replaced every 6 months after they've entered service. If the gloves aren't being used yet, the first test or replacement can occur as long as 12 months after the gloves were purchased. Glove manufacturer can provide a list of approved testing facilities. Hybrid and electric vehicle service plugs can come in many different shapes and sizes. The procedure for each manufacturer should be followed accordingly with their specifications. Venting issues can also cause problems. Always check for anything blocking the venting systems on hybrid units. When diagnosing any hybrid, use a compatible scan tool. Extract and record the data and the codes in every module. Using the code criteria, information from the manufacturer monitor the scan tool data to verify whether the component is working correctly. In these two illustrations, you'll see on the left side commanded motor torque, actual motor torque, and motor RPM. These are normal, routine conditions. On the right-hand side, there's a code P0521 system malfunction. You'll notice the command motor is oscillating, the actual motor torque is oscillating, as well as the motor RPM. This will conclude our theory and operation course on general hybrid introduction and safety. We want to thank you for your participating in Virtual Training Solutions powered by ATRA. Until next time, let's keep fixing transmissions together.